Greetings! In this video, I am going to attempt to take apart a ship that I've been building, which I finished building yesterday, show you all of its insides, its guts, so to speak, show you the individual systems that make it work, how they work, and then once I've shown all of those, I can essentially show you how the ship works. The ship that I built is attempting to emulate the Corsair from Star Citizen. It is an asymmetrical design, which makes it slightly complicated, not that much more than usual. It is a large ship, it's quite heavy, however, I did manage to get it working properly. So I have colored all of the logic that I used to make sure that it's in evidence, and we're going to go through how it connects up to all of the ship's pieces and parts and what it does. First and foremost, I should talk about how this creation actually flies. It flies using the hover block glitch, which is whenever you face a hover block, such as this one, into a piece, right? You just slap anything at the bottom, then it will become essentially a thruster in the direction of the flame. So it's as if I have a dragon jet facing in this direction, because the hover block will provide push in upwards and a flame going down. And so the dragon jet does virtually the same thing. It provides a flame going down and push in the upwards direction. This is how, in essence, the hover block glitch works to make spaceships fly. Now, one of the interesting things to note about the hover block glitch is that it is very slow. It does not provide a lot of speed. However, it does provide a lot of force. So it can lift small things slowly, but it also will lift very, very heavy things slowly, which is very handy when you're building something enormous, such as I do occasionally. The first block is a simple constant output block. It's got a constant output on a positive scale, and it makes it so that these two hinges create a slope on this side. That is the very, very simple function of this. The second system is also very simple. It's an input for Q, which outputs to these three hover blocks. All hover blocks are by default active once you jump into the creation. Once you enter the cockpit, all hover blocks will be active. Therefore, to deactivate them, you have to give them an input. So very simply, in order to move downwards, since all three of these 1, 2, and 3 hover pads are facing the downward direction, therefore giving me an upward thrust, in order to drop very slowly, I deactivate them with Q. In order to know that I have deactivated them, I have these lights that are also activated. Every single one of them has a duration of 0.1 and a pause of 0.4. And then incrementally, they have a delay that goes up by 0.1 every step. This gives an effect as such. So I will press Q now, and as you can see, it has an indicator telling me that, in fact, it is on. That way, even if I am very high up in the sky and I have no ground reference for whether I am moving up or down, or whether my Q block is active, I will know because of the indicators. This system is divided in two. As you can see, there are two slightly different colors here. This system is the backwards and forwards system. So these speed sensors activate the thrusters. So this speed sensor will activate the forward thrusters, the forward facing thrusters, in order to stop the ship if it is floating forward without reason. This speed sensor will activate the backward thrusters. This is in order to keep the ship stable and not just floating away whenever you don't want it to. So by default, those two speed sensors will simply activate these thrusters, right? And the thrusters will attempt to keep the ship in place. So as you can see, it's moving slightly backwards now, and so the thrusters are stopping it. And once I move it forward, I will now give it some forward momentum, and the forward facing thrusters will indeed stop it. In addition to that system, I have to add on forward momentum, which is space, and backwards momentum, which is left shift. Essentially, the concern is if I simply key key both of these inputs into the thrusters themselves, the speed sensors will stop me from moving forward. I will press the space key and all of these backwards facing thrusters will activate, and then the speed sensor, this one, will alert these thrusters that we're moving forward and therefore will stop them from functioning. Like, there will be just as many thrusters pushing me backwards as there are pushing me forward, and therefore I will go nowhere. Right. So how to counteract that? I have these two keys. So obviously space activates all of the backwards facing thrusters and left shift activates all of the forward facing thrusters that are both keyed into, they both input into AND gates, right? The AND gates also receive input once the speed sensor has activated on both sides. And then the AND gate, so if the speed sensor is active, therefore we are moving forward, and at the same time I am pressing an input to move forward, then this gate will, the AND gate will receive both of those signals and activate with a negative scale output in order to stop the forward facing thrusters from stopping me, if that makes any sense. The same works for the backwards facing thrusters. And therefore, the result is I have no inputs at the moment, and as you can see, my ship is stabilizing by itself, and then I will press space to move forward, and the red output on the AND gate is impeding the forward-facing thrusters from stopping me. And then once I deactivate the space input, then the forward-facing thrusters will stabilize me in the air. The next system we will discuss is these 4 logic gates. It's not particularly complicated. They are working in tandem with these 2 distance sensors. So these 2 distance sensors are detecting the ground, obviously. They are for all of the automatic landing functions. So this distance sensor is on a distance of 5, as exactly the same as this one. They both output 1, except this one has an inverted trigger and this one does not. This means that, very simply, one of them will be active at a time only. So once you get to 5 meters, they switch. Basically, that's the crux of it, is once you get below 5 meters, one is active, and then you lift above 5 meters and the other one activates. This means that I have a constant output for both of the conditions. Are we above or below 5 meters? Let's discuss what all of the landing functions do. So, Once below 5 meters, I have this distance sensor hooked up to all of the rotating servos on the wings and to these two pistons. It has a positive output, therefore the pistons will extend, and the rotating servos, I've made sure that all of their speeds are correct so that they all rotate in the upwards direction. So they rotate towards the top of the ship. And same for this one, these ones. They're all set to 90 degrees so that they all come to be perpendicular to the ship as such, right? And then, in addition to that, this distance sensor activates these two logic gates, which both of them will control, on the one hand, the back landing gear, and on the other hand, the forward landing gear. Of course, the XOR gates on top here have not whole scale inputs. They don't have 1 or -1 as inputs. They have percentage numbers in order to give the hinges at the bottom strange angles, which creates, as such, a formation for landing that is quite interesting, if I do say so myself. The other distance sensor activates all of the hinges. All of the hinges are set to 90 degrees. I will show. They're all set to an angle of 90 degrees. And therefore, the other distance sensor, once above 5 meters, will make it so that all of the landing gear folds up properly. And at the same time, will activate these two logic blocks, which key into both of the rotating servos on this side of the ship. So the top two and the bottom two. This will give an effect that is as such. Once above 5 meters, the ship's wings will fold out. The large wing does not need any additional inputs because it is already from 90 to 0 degrees. The other two wings instead require additional input in order to give them this peculiar formation. Rather interesting formation. Half the reason why I built this ship to begin with is for the very interesting wing design and asymmetrical shape. So again, in order to achieve these angles, I have a percentage scale output. So this is 60%, not 100%. 1 is 100%. And this is minus 60% in order for the wings to have a sort of an angle to them. And there we go. So these are all of the landing function, the landing and not landing functions that these two sensors activate. This is the end of the first of two parts explaining the functions and the systems within my ship. The second part will complete the description of the ship's systems, showcase how it flies and how its weapons work.